So hello everyone. This video is about the roadmap for the analog engineers. Okay, so today we are discussing about the roadmap. So first, let's understand if you are in the IITs or top IITs or top NITs or any IIT, and you have various kind of roles. You have the option to choose various kind of roles. Like first is let me choose my pen. Uh, First is analog design engineer, analog layout engineer, analog mixed signal engineer, or analog FAE engineer. FAE means field application engineer. So these roles are offered for many IITs and many top NIT. But if you are in lower colleges like some lower colleges like NSUT, DTU, or IGGW, or many lower colleges, you can see the roles about analog design engineer, not layout, not mix signal. In some college, you can see analog FE engineers also. Okay, so let's understand about these roles. First, understand about these roles, then we will discuss about the roadmap. Okay, so in analog design engineer. In analog design engineer, you have to actually design the whole circuit, like how the signals are behaving, how the what's the size of transistor, means what's its length, breadth and length, selections, transistor size selections, or what is the current and voltage swings of the transistors. And these kind of the work you have to done in analog design engineer. And one of the toughest this role is the toughest amongst all these roles. So yeah, this one is a high paying job around 40 lpa, 40 to 44 lpa. Okay, and in this you have to design the analog blocks also, like op amp, differential pairs, like something. And in analog layout engineer, in analog layout engineers, eh, you have to design the whole chip, like how transistors are aligned on the wafer. Like first, in the lithography process, first you have to uh, imprint the patterns, and then aligned, and then there is several processes like etching and all. Then all these processes are done by analog layout engineer. And this engineer actually designs the chips, like how transistors are drawn on the silicon wafer. Okay, uh, in this you have to in this engineers use various layout technologies. Okay, in mixed signal design mixed signal design role is uh, kind of the bridge, not gap, kind of a bridge between digital and analog circuit. How digital and analog circuit behaves, and how they contribute, communicate to each other. So, analog mixed signal design engineer ensures in this domain, like how digital and analog works. Okay, and it also verifies circuits like PLL and band gap band gap circuit. And in analog FA roles, engineers mainly have to mainly have to consult the customer, or give the guidance how to use the chip, how to use chip. And it also the engineers also listen to the customer, like what their requirement, what they need, and what their specification. And in this manner, in all these requirements are tell to analog design engineers, and the fabrication process begins. Then it goes to analog layout engineer. Okay, so in analog FA engineers mainly deals with customer, and there is also a technical part here. So it's kind of mixed part between core role or non-tech role. So in 70% are core and 30% are non-tech. So these are the complete analog profiles. This is the analog VLSI role, all analog VLSI roles. So now I am discussing how to learn all the topics to eligible for all these roles, like to crack all these roles. So first to discuss, I am discussing like if someone in first year, second year, or third year, or maybe fourth year student as well. For fourth year student, uh, there is an another path different from the first, second, and third year students. Okay, so for the first year, like I will discuss for the first year students. For the first year students, like currently you are in your first sem and or second sem, so you are basically familiar with basic electric or electrical circuit, basic electrical circuit. So first you have to clear the basic concepts. Okay, like what basic concept you have to clear. So in basic electrical, you have studied the KVL, KVL, Thevenin, Norton, okay, or basic RC behavior, RL behavior, RLC behavior, LR behavior, okay, or so in RC, RL, RLC behavior, mainly you have to focus on the discharging cycle of the capacitor, how it behave when there is more resistor and more capacitor in the circuit like this, and mainly you have to focus on the charging and discharging equations. Like for the charging equation, equation of the capacitor is uh, V final plus V final initial minus V final E minus T by tau. This is the charging equation of the capacitor, and then discharging is the different one, like the final voltage and the E minus T by tau. This is these kind of the equation you have to focus on the basic electrical system. I know it's not a basic part, but you have to focus on these topic first. First, clear the concept of KVL, KCL, Thevenin, Norton, then RC, RLC circuit, and there is more theorems like maximum power theorem, and consider some two-port networks as well, because these part not this is not for the interview one, but the question of the there is two-port questions on the screening test for the companies. So focus on the network as well, and power equations, energy equation, capacitors. These are the some basic part. First cover this, and to cover this, make sure you are covering your basics very carefully. Means don't make shortcuts for this. Uh, understand clear understand everything and every steps clearly, and then move to the next part. In the next phase, now if you understand all this KCL, KVL, and this is the first time and second sem student. If you are in first and second time, you familiar with all these kind of topics, and now you are now if you move to the second year. In second year, you you are introduced to the EDC part, electronic design circuits. So in this EDC part, you will get to know about the PN junction, diodes, BJTs, MOSFETs. Okay, so these are the device physics. In device physics, you have to understand the behavior of the behavior of the diodes, how the diode behaves, in behavior of the MOSFETs, BJT, and the MOSFET part. In this, you have to gain the knowledge about the region of the operation of the PN junction, like when the PN junction is forward bias, when the PN junction is reverse bias. You have to understand these topics carefully. The dropout voltage of the diode also, And for the BJT part, you have to understand the BJT's regions of operation, like there is a cutoff region, saturation region, or forward active region, uh, forward active region for the BJT, and as a small signal behavior, not small signal behavior. We leave it for now. If you are in second year or in second, third sem or fourth sem, you have to focus on the EDC, P-N junction, BJT or MOSFET, mainly a device physics, how P-N junction behaves, how BJT behaves, how MOSFET behaves. You have to understand everything clearly with the energy band diagram as well. I will suggest energy band diagram as well, because if you understand energy band diagram, you can understand the every equations of the BJT, MOSFET, and P-N junctions. So, and in BJT, BJT, there is you have to consider the RO effect. Why this RO and GM also. GM is a transconduction with the BJT, and same for MOSFET. MOSFET has the three region: cutoff region, saturation region, and triode region. How MOSFET behaves in this region, and also RO there means the channel length modulation of the circuit, and the GM part, the transconduction. You have to understand all these topics clearly clearly between your third to fourth semester. No need to uh, मीन्स जल्दी करने की कोई जरूरत नहीं है, आराम से ये सब पढ़ो. Then move to the next phase. The next phase, uh, now you are in third, or you're in the fifth semester or third year. In third year now, in third year now, you know about the basic RC circuit, RL circuit, KVL, KCL, Thevenin, EDC, PN junction, BJT, MOSFET. In this time period, you uh, solve many gate question as well, gate questions of EDC and the network part. Okay. In the KCL, in the network part, understand about transient analysis like AC and DC analysis also. Okay, I forgot to mention this one. So I'll also understand the transient analysis. Okay, and then if you complete this part or this part, then solve the gate question to make a better understanding of the topics. Now move to the third year. If you're in third year, now in third year, you are familiar with the BJT, MOSFET, and PN junction concepts. So you also learned about, by the end of the second year, or in the start of the third year, you are also familiar with the SNS part, signaling system, control system. So this will eventually benefit you in the analog part. Oh, because there is some concept which are mixed with the SNS and CS part. CS is the control system, and this is the signal and system. So now in third year, you have to move to the next phase of the analog circuits, where 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 you have to uh, in this part. Now BJT and MOSFETs are combined to make some circuit which are performing some functions like amplifying the signal, or buffering the signal, or there is many part here, like high frequency behavior of the BJT and MOSFET as well. So all these things you have to learn in your third year. Okay. So in third year, and uh, understand all this on the third year, like what is the what topics you have to learn in the, like uh, single stage op amp, single stage op amp, differential pair, current mirrors, or cascode structures, cascode structures, cascode structure, and two-stage op amps, two-stage op amps, and also, band band gap reference, band gap reference. One this this one is for the third year, but in many colleges, companies come for internship part, in the college. So for the internship, you have to cover all these topics by the end of your by the end of your uh, by the end of your second year. But for the internship part, they didn't ask much. They didn't ask much in the interview. So you can always follow this path in the second year. But I will suggest in this in the at the end of the second year, you have the knowledge of gain the knowledge of op-amp or current mirrors, casco structure, two-stage op-amp. Like two-stage op-amp is not mandatory for the internship part, but for the safer side, if you have the time, you can learn the two-stage op-amp. Okay, so uh, what you have to cover before the second year for the internship part? This part RC, RL, RLC part, okay, EDC part, okay. But at the end of the second year, you gain the knowledge. You learn about op-amp, current mirrors, casco structures, differential pairs is important. So learn all these topics before the end of your second year. And like in the interview part, they don't ask much about the two-stage of band gap reference. But I will suggest if you have time, you can watch this topic as well. So if the internship session is over and if you're in third year, so definitely you have to learn all these topic like single stage op-amp, differential equalizer, current mirror, cascode structures. Cascode structure is very important as the question on these structures comes in the screening part as well. Screening part and the current mirror is as well are important as these question are comes in the screening part of the screening part of the companies means OA online assessment. And in third year before the end of second year as well, I will mention one more thing like you learn the small signal model of the BJT and MOSFET as well. uh, and then all this part small signal model is done, and uh, learn about trade-offs as well, write down all this topic I am writing. Like I know it is kind of mess, but understand what I'm saying and then write on the notebook. Okay, trade off like what is the gain versus what is the gain versus speed versus power. Like in the trade-off we have to maintain all these parameters. Like we can't make gain much higher, not much speed not much higher, power not much less. We have to maintain some decorum uh, to maximize the efficiency of the circuit. And the important part in the third year, now by the end of fifth semester and then in the end of start of the sixth semester or the end of the sixth semester, you gain the familiarity with the RC circuit, RL circuit, RLC circuit, all this network theory part, all this EDC or diode physics part, device physics part, and then you gain the knowledge about op-amp, differential pair, current mirror, cascode, two-stage op-amp, band gap reference, and also you know about small signal model, BJT and MOSFET. The small signal model is very important. Very star mark this small signal model is very important for these kind of the roles. And now uh, band gap reference and one more thing. What is this? uh, High frequency analysis of the devices. Uh, this one you can skip, but if you have time, you can learn high frequency analysis of the circuit, analysis of the circuit. And one other thing, like you have to learn about the feedback of the system, like what is the effect of negative feedback, positive feedback, and there is many more questions about the feedback. So learn about the feedback as well. Now, if you gain the knowledge, theoretical knowledge, now come to the project. For the projects part, first learn the LT-SPICE. LT-SPICE is the open source project, op open open source simulation tool. So learn about LT-SPICE. LT-SPICE will LT-SPICE introduce you to various technology, various analog circuit designs, analog circuits. So in the LT-SPICE, I will suggest this. Simulate some RC filters, RC circuit filter, RL circuit, RLC circuit. I as well upload some videos on the LT Spice simulation. So when you simulate simulate some RC filter, RLC, RL filter, some filters, then you will get the knowledge how to use LT Spice, and what parameter to set, and also learn how to use the AC analysis, DC analysis on the LT Spice. Build some project like oscillator. There is some oscillator like Wien bridge oscillator, and Wien bridge oscillator, and there is one more famous one. I forgot the name, but I will suggest search about oscillator on the YouTube, and you will get some of the best videos on the YouTube, and then learn how this oscillator is behaving and simulate this kind of behavior on the LT Spice. Then if you learn about LT Spice, then go to the industry level tool. Industry level tool is cadence vertigo. Uh, this is the industry level tool where you can learn the various technologies like TSMC 1T nanometer technology, or many more technologies, nanometer technologies, or PDK files again. Like, so if you simulate all the circuit on the list LTSpace, you can simulate as well on the Cadence Vertigo. But Cadence Vertigo is not an open source software. You have to get the access from your university professor. So ask the university professor of your university, then use Cadence. All things you can all things you can simulate on the Cadence can be simulated on the LT Spice as well. If you don't get the Cadence subscription, then don't worry, you can do all the thing on the LT Spice as well. So my suggestion is learn LT Spice from your first sem. If you are watching from if you are watching till the video, learn the LT Spice from your first sem, and simulate basic RC RL circuit, RLC circuit, and made ADC and DAC converter as well. So you will get various knowledge about all the circuit, and you will get how to use LDSPICE. You will get familiar with the interface, and the voltage part as well, simulation part as well. So now I will tell about what to make on the LDSPICE as your final year projects, uh, to write on the resumes. So in LTSPICE or in Cadence, sorry, in LTSPICE or in Cadence, first make a two stage two-stage op-amp with frequency compensation. Like, if I am not wrong, it's a frequency compensation. Let me verify. Uh, Wait a minute. Mm, yes, so with it's right, it's correct. So two-stage op-amp with frequency compression. Second, second, you can design band band gap reference, BGR. You can design band gap reference circuit as well, two-stage op-amp circuit, and more projects you can add like ADC and DAC circuit. And this can be designed physically, means on hardware level. Uh, uh, Make sure you do a correct signal analysis and power analysis of the circuit in the ATC and DC part, and you can make as buck and boost converter as well. Buck and boost converter as well. It means how can you design from scratch, like select L, select R, select capacitor, select MOSFET, based on your design, like what you need. There is many more formulas how to calculate inductor L, capacitance of C, resistance R, and how what MOSFET to use, what duty cycle you need. You can design, think like an engineer, not like a technician. So design in such manners that uh, uh, first fix your requirement, like what you need, like what voltage you need at the output, from 5 volt to 15 volt for boost, or 5 volt to 3 volt to for buck converter. And for for these voltages, there is some factors like duty, how much duty cycle you need, how much duty cycle you need, unit in the buck converter as well. If you are designing a buck and boost converter, I will suggest design with the feedback system. Why feedback? Because if this is a buck converter, let's suppose this is a let's suppose this is a boost converter, and you are in boost converter, there is input supply is 5 volt and output supply is 12 volt. But if you connect any load here, then the load will consume some current, and there is some voltage here. Due to this voltage, a voltage drop will occur on the boost converter side, and this voltage will drop, like it will drop from 12 volt to 11 volt or 10 volt as well. So to maintain this 12 volt, you have to maintain the feedback system. So you can learn about the feedback as well from this systems. Okay, so I will suggest make buck and boost converter. You can make this physically, you can make this one is these one are physically as well, and design with the feedback system. And this is band gap reference system, this is simulation based as well. Learn some arduino programming Arduino coding, Arduino programming, like or you can learn about ESP32 as well. Like these are the basics. You can learn anytime, but I will suggest learn Arduino, how to program Arduino, how to program ESP32, so that you can perform all these experiments if you go for hardware basis. Okay, so this is the complete this is the complete roadmap for the VLSI role, analog VLSI role. Like what you have to learn, what projects to make on your final year. Also, if you don't secure internship in the analog hardware in on campus, then don't worry. Search on the LinkedIn as well. Search on the LinkedIn's, or try to find internship on the hardware level. You can't find internship on the analog IC design level internship if off campus, but you can find hardware level internship off campus. Okay. So this is the complete analysis for the first year student. Second year student can also follow, but for the internship part, you have to make an extra efforts to uh, outsmart or uh, other candidates. So you have to learn about and to end before to the end of the second year, or before your internship session, you have to learn about the op-amps and these differential circuits. I suggest here differential circuit, different uh, differential pair current mirrors as well. So for the internship part, you have to make an extra effort, and if you don't secure an internship uh, in your second year, end of second year, for the placement part, you have to follow this roadmap that, that I talked about. Okay. All these projects is here: two-stage op-amp and band gap reference, buck and boost converter. These all are the projects you can follow and learn some other basic skills like basic programming, Arduino programming, or C++, or Python as well. This will really help on campus or off campus as well. So now for the final part, I suggest I talked about the simulation tools as well, and what uh, and for extra part focus on noise analysis, as this is the crucial topic in the analog IC layout IC design engineer. Noise analysis is a um, crucial topic, and this will differentiate a normal candidate. This topic is differentiate between normal candidate and a smart candidate. So learn about noise analysis, stability analysis, and mainly noise analysis and high frequency analysis of the circuit. So if you have time, you can learn about all these topics as well. So what left to discuss? Mm, So I think nothing left to discuss for the roadmap. But now I will discuss how where to learn all these topics. Okay. So to learn RC and RL part, to learn RC RL part, RLC part, follow Chembiyan Sir, Chembiyan T, Chembiyan T playlist. I will drop link in the description. So follow Champion Teaser for RL, RC, RL, RLC part, basic mainly basic network part. These are the some of the best lectures on the YouTube available on the RC RLC circuit. If you follow all these lectures from the scratch without any skipping, without any fast forwarding, you will learn RC and RL. Uh, you will means एक बार तुमने देख लिया तो तुम कभी ये भूल ही नहीं सकते. लाइक ये मेरा पर्सनल एक्सपीरियंस है. दिस इज माय पर्सनल एक्सपीरियंस वे द फर्स्ट टाइम आई वॉच द लेक्चर्स एंड राइट everything. I didn't forget any of the part. So, but you have to continuously revise the topics, means in one in a month, or two in the month, two times in a month, so you don't forget any of these topics. So I will suggest RC RL part, basic RLC part. You have to follow Champion Sir. I will show the playlist as well. And for the analog part like all the op amps, BJT, MOSFET, and the feedback circuit. So watch Razavi Sir. Razavi Sir's playlist is best, best among the best teachers. uh, the lectures length around 1 hour, and you didn't feel any boring lectures. You will feel like an energy. You will feel like these lectures are energetic. If you start watching, you won't quit. So follow Razavi sir's both playlists, electronics 1 plus electronics 2. These two playlists are goated. You can learn whole analog part here. Okay. And if you learn analog part more deeply, more deeply than Razavi sir playlist, then I will suggest after you complete. And I don't suggest directly jump on this playlist. After you complete Razavi sir's and you have the passion to learn analog, watch Ali Ajmeri sir's Ali Ajmeri sir lecture. Search an analog Ali Ajmeri. Of course, you will get a playlist where you can see lectures, real-time lectures, uh, and the lectures of the Razavi sir are follows on the device physics. Like you can learn EDC from here as well. These topics, these lectures are starts from device physics to advanced analog concepts. Advanced analog concepts. So yes, Razavi sir starts from energy band diagrams, and then discuss everything about differential pair current mirrors, feedback circuits, high frequency analysis of the circuit. So I will suggest first watch Razavi sir. Then if you watch Razavi sir and solve some question from the Razavi sir books, there is one book as well, Razavi sir book. Her name is Simos Design something, like I forgot the name of the book. You can search by the name of the Razavi sir, then watch Ali Hijmir. Once first you watch this, then this. Okay, so I will see you the playlist as well. So uh, this one is the playlist of the Chembiyan Sir Introduction to Electrical Science Passive Device AS, and 62 62 videos, and this is Razavi Sir's video, Razavi Electronics. 90 videos is there, 91 videos is there. You have to watch every video, each and every video. Don't skip, watch patiently. And this one is as well, if you have if you really have a passion about the analog, you can follow these lectures as well. Okay, now back to our discussion. And now for the discussion is here. As a senior, I will suggest you to maintain the higher CGPA cap. Like if you are from the lower colleges, okay, like if you're from lower colleges, like I will say, like in DTU, NSCT, or IGTW, or any other college like PEC college. The In this college, there is a core companies comes, the reality is, you have to maintain the high CGPA, maintain high CGPA cap, high CGPA. Like high CGPA means 8 or above 8. Like sometimes company uh, set the cap of 8.5 CGPA internally, not officially, but internally. Like what the reality of the all these companies in these type of colleges. Like first companies open around 7 CGPA or 7.5 CGPA, and they will shortlist. And sometimes they will not shortlist they will not shortlist. I don't know how they will shortlist, but sometimes they didn't even give the chance for the online assessment part. Okay, so for the online assessment part, but then uh, uh, but then online assessment part, if your online assessment is good, you feel like you will definitely get the chance of the interview. But sometimes it's not happened. This will not happen, because if there is 100 student sitting for OA, and in among the 100 student, 70 students perform good, or 50%, if we take a 50% margin, 50% student do good, then the company don't have time to take the interview of the 50 student. They will take some of the students, so they will set the cap of 8 or 8.5 CGP internally. Okay, so if you are aiming for the core branches in these colleges, make sure you have the high CGPA cap. Okay, high CGPA around 8 or 8.5 mainly. Don't get in the trap of 7.5 CGPA. If someone is saying 7.5 CGPA is good, then ignore them, and build your CGPA 8 to 8.5. Okay, this is my advice. So to aim these type of roles, you have to maintain the 8.5 CGPA, and this 7 and 7.5 CGPA are kind of a scam. Like uh, they set the internal criteria for 8 and 8.5, and mean also, this is the if someone is watching this video to the end, that the final advice from me to maintain aptitude, maintain aptitude means practice aptitude thoroughly or seriously. Like people often ignore aptitude, and then end up making silly mistake during OA, online assessment. So keep in mind, like aptitude is also important as core subjects. Okay, so this is my final advice to you. Uh, if if someone is watching this video to the end, then thank you for watching this video. Thank you. I will attach all the documents in the description as well. Like I have some of the document of the Texas Instrument. Uh, oh, एक minute. Okay. In this Texas Instrument document, this document are made by the TI engineers. In these type of document, they tell about how uh, how to prepare like basic electrical science. These are the playlist they are suggesting. Then analog circuits, signal and system as well, and control systems, and these are all the thing I said are mentioning in mentioned in this PDF, and then same for digital and same for embedded. So I will attach all these document, and if you want a dedicated digital roadmap, then comment for the dedicated digital roadmap. Then I will make a detailed analysis as well. So thank you for watching this video, and I will attach all the document in the description. Okay.